Hey folks, and welcome to Advent of Code in F Sharp. Day 21 already. Last couple of days have been a bit spotty for me. It's like the end of year. All things at work need to be finished. So I'm running a bit behind on my star fruits, and I also have a little boo-boo right below my nose. A shaving accident, so don't mind too much attention. But let's dive into day 21. I've dabbled into the previous days, but there were some interesting problems in there with some heavy computation or some heavy optimization. And I will definitely return to those later, but for now, let's take a look at day 21, monkey math. The monkeys are back. You're worried that they're going to try to steal your stuff again, but it seems like they're just holding their ground and making various monkey noises at you. Eventually, one of the elephants realizes you don't speak monkey and comes over to interpret. As it turns out, they overheard you talking about trying to find the grove. They can show you a shortcut if you answer their riddle. Each monkey is given a job, either to yell a specific number or to yell the result of a math operation. All of the number yelling monkeys know their number from the start. However, the math operation monkeys need to wait for two other monkeys to yell a number, and those two other monkeys might also be waiting on other monkeys. So our job is to work out the number the monkey named Root will yell before the monkeys figure it out themselves. Okay, so we have monkeys that each either know a number or know an operation, and it takes two other monkeys, or the numbers from two other monkeys to complete. Makes sense. Low number, yes. A job means addition, subtract, multiply, division, yes. And they have to wait for each other. Do we have to model the time, or do we just need an end result here? Yelling a number, sure. Then the monkey, this allows it to yell its own number by finding. Yeah, that's just doing the calculations. We have considerably more monkeys. I already grabbed my input to get started, and we do have considerably more. We have somewhat around 3,000 monkeys. That's a lot, but not a ton. And we just need to figure out the root monkey's number. For 3,000, does it make sense to work backwards from root, or to just calculate every monkey? Probably we will need to calculate every sum. Maybe not. Will it? Let's try some sampling of the data. Does every monkey occur twice? This is a very rough and yeah, probably every monkey depends on someone else, and root depends on everything implicitly. I'm gonna hazard a guess, and probably that will be the case, but we don't know. I'm gonna start this very naively. Only 3,000 lines, and every line has at most 2 dependencies, so that's doable. That's not a crazy amount of calculations, right? How will we model this? We have hashes or unique IDs for monkeys, and they all have either a number or an operation needing other monkey numbers. Do we need these weird IDs for a monkey? Can we just translate those to indices? For example, LSDF is the first monkey, so he gets, or they get the index 0. And then we figure out the index for the other ones. Will that make things easier? No, not really. I'm debating whether I should use a lookup table mapping a monkey ID to whatever is on the right-hand side, or to already try something smarter and work with, I don't know, something with constant indexing like an array. Because lookup tables are a bit slower, a teeny bit slower. Maybe we'll do an array index optimization. That's not too big of a mental leap, and that might gain us some precious CPU cycles. So yeah, I think I thought enough about the problem, so now we can try coding it until we get stuck, and then we'll put on our design hats again. That's something I learned from Jessica Kerr. Let's see if I can find the tweet or the quote. Something about interaction between designing and coding. Yeah, I think this is the one. There we go. Brilliant quote. Design until you feel you understand the problem, and write code until you realize you don't, and repeat ad infinitum. This was a wisdom from the 1960s already. So yeah, I still live by it. We did our designing. Let's go and write some code for this. So I also grabbed the example that's a bit smaller, so we can go over it quicker. What do we need to do? Let's do the translation of a monkey ID to its index, and let's parse every line into either a monkey number or a monkey number that still needs some calculation, and then put how do we figure out what's the next thing? We can just brute force and try everything. Yeah, let's not build a graph or a dependency tree just yet. Let's just naively brute force this. Let's just naively brute force this. Maybe let's not even do the indexing thing just yet. Let's just keep a mapping a monkey ID to whatever is on the right hand side of it, and try to do some kind of fixed point operation. It will crash and burn for large data sets, but at least then we have some types to evolve, or some data structures to evolve. So let's think about types. I'm gonna call them monkey numbers, monkey job. That's a good thing. So it's a job, and a job is either a number, and is it always an integer, or are they always small-ish? Or do we have large numbers in there already? We have 3,000 and they multiply, so 9 times 9 times 9 times 9. Yeah, that can get up to what is that, 10 to the power of 3,000? That's a big number. Let's take along by default. So we have a job is either yelling a number or having an operation. Or a calculation, and that is an operation and two operands, like, right? Yeah. And let's give our monkeys a type, and that's right now that's just a string, but that will probably evolve into something else. So we have a calculation, we have an operation as well. Do we need types for this? Yeah, let's call it add, subtract, multiply, and divide. And the calculation is a monkey. Is it always a monkey, or can it be a number as well? Should we be partially filling in operands once we calculate them? That's also an optimization we can do, but for the input we don't really. So let's just keep it a monkey ID and an operation and another monkey ID. So yeah, I see a lot of room for optimizations here, but let's keep it simple for now. I think that's it. Now if we parse into monkeys and their jobs, I think we can get started. So let's parse a line here. Lines are strings, so a compiler can help us do stuff. what does a line look like again? Let's grab the first one from the example, which is root, and let's take the second one, which is the other case. That looks like a simple parse. We can get away with string splitting. Of course we can. So if we split on this, we get the monkey ID and the right hand thing. And if we destructure that, into a monkey and its job part, and then we can try to parse the right hand side into an integer or long. If that works, we have the number, and otherwise we can parse the calculation. It's time for active patterns again. Yeah, it's time for active patterns. I don't know if we've already used them this month or this year, but it's a good match for this kind of thing. So let's pattern match on job. And if it is a number, we return the number. And otherwise, if it's a calculation, we return a calculation. And these things don't exist yet, so let's conjure them up with the banana clips partial active pattern thing we've seen before. And if not, we can leave a link in the description. So this is called partial active patterns, and they're a way to write cases for a pattern match within an open-ended list. So I can declare a number, and somewhat later in the code I can declare a calculation, and a year later I can declare a third case, and it all works automatically. It's like an alternative to these closed lists or closed enumerations of all cases for a sum type, or what is this called? Yeah, it's a sum type, a choice type. So yeah, partial active patterns it is. So if job try parse, yeah. So if we can try parse this job into a long or an int64, we have our number, and otherwise we have nothing, and then this case does not match anything. And I think partial active patterns need to return an option. What's going on here? Is this not the pattern matching syntax? Yes, it is. What's happening? Try parse job is not compiling for some reason. Do we need to provide the type? Why is this not working? Oh, I forgot an underscore here. Oh boy, that was... Yeah, okay. Still not happy? No, okay, you can know it's a string. I'm fine with this. So this is matching a number, and then we return our number case, and if it's a calculation, we can cheat a bit and know that a calculation match happens after the number match. It's not really the cleanest of designs, but hey, it's Advent of Code. We're just grabbing Starfruit, right? So we know that it's not a number in this case, so we do know it's a... Nah, we can do the try parse as well. So let's do... let's split on what? On space? Yeah, let's split on space. And let's destructure as well. So that's left operation right, and that is the job split on space. And we can just return calculation of L, whatever, and R. And then we need to parse out the operation. So match up, let's do a pattern match with If it's a plus, we add, and so on and so on. And that always returns a valid case. Yeah, we're not gonna deal with edge cases or errors. This is good enough. We multiply and we divide, right? So yeah, we have our parsing in place, I think. And now we can return our... That's the job, that's the monkey. Now we can return our line parsed, which is the monkey and its job. That's our parsing done. Let's see if this works by parsing those two examples we have here. So let's see if we can parse the simple case first, the number. And that should be monkey dbpl trying to do a number job with the number 5, right? That appears to work. I haven't seen it fail because we're not test driving, so let's make it fail. Yeah, that fails. And let's parse the other case, the root monkey. And that's root monkey trying to do a calculation of w added with ce, je, me, ne. So that should also parse. Yeah, that's parsing correctly. Let's put those tests in our test framework, test harness. There we go, we can parse. That's the first step done. So we haven't done anything actually, we have just parsed. Let's make sure we can parse our input as well. We haven't forgotten anything, that seems to work. And the example, can we parse that? So we can continue work, yes. Cool, cool, cool. Am I happy with? I think this small example, we can do a very naive approach. So let's do that first. Yeah, we're not trying to win any leaderboard spots here. We're just trying to get our star fruits. So we have a lot of... Can we actually recursively descend? So let's say we try to calculate root and then we see, oh, we need these two. And then we try to calculate these two recursively. Oh, we need these. I think we can just do it that way, right? And we can add some memoization to make it faster. Actually, that might work for the entire input. So yeah, let's just try to calculate a monkey ID given jobs, and that should give us whatever along, right? So do we need a lookup table? That's logarithmic, a list is linear. Yeah, let's make a lookup table. So we have our list and now we have a lookup table mapping what to what. Mapping what to what? Mapping monkeys to jobs. Yeah, that makes sense. So let's find the root first. So let's try to calculate root given our jobs. What do we need to do for that? Let's figure out the actual job. So that is lookup in jobs the monkey, yeah. And then pattern match on the job. If it's a number, we're done. If it's a calculation, we perform the calculation given the jobs, because we need to look up stuff and we might do some memoization later. Cool. Let's build a smaller function. We're programming by wishful thinking here. I'm dreaming up the functions I wish I had, and next I try to write those. And piping in this calculation constructor, so our types remain safe, or our type structure remains the same, and we're not piping in monkeys where we expect calculations, stuff like that. So we perform a calculation given a current context of certain jobs or a current state. So a calculation is always left, up, right. Let's destructure that in the function signature just because we can. And we need to figure out left and right. So yeah, we need to figure out left and right. So let's try that. Let's say, do we need to perform? No, those are monkey IDs. So we can just recursively look those up or recursively calculate. It's a recursive calculation, yeah. So we're going to do mutual recursion. We've seen that this year already. It's two recursive functions calling each other recursively. So the left value is calculate left given the jobs. Right is the same. And then we do the calculation depending on what op we have here. So do left plus right minus multiplication division. Subtract, multiply, and divide. And let's put that in its own function called apply operation. So that's a pattern match. That's a simple pattern match with left and right operands. So let's pattern match and let's call those left and right. And I did like the one-letter things for brevity, not for clarity, but this simple function makes sense. So if we have left and right, we can just apply left, right, up. And now that I'm seeing this, I don't like the order that this function expects its arguments. I would expect op to be in between. Yeah, let's keep it in between. So it's an explicit pattern match. There we go. This will burn my precious CPU cycles because we're going to do a lot of, maybe we're not doing a lot of duplicate calculations, but I'm guessing we are. So yeah, let's see how intense this calculation is, and then we can optimize if and when we need to. I pressed the wrong buttons here. Yeah, so we have 57. It appears I have my it appears I have my basic maths wrong. That's interesting. Huh? Let's print out our jobs. That is somewhat surprising. Okay, let's see if we parse everything correctly. CCZH SLLZ LGVD. And that's an add. Yeah, we have. Let's grab a subtract example. PTQDQ. Let's dive into troubleshoot mode and print out our job. So we have setc2l. Yes, let's find a subtraction ptdq. I found our bug. We're always adding. That's not correct. I duplicate lines without fixing them. So where is our parsing here? We're not really. Huh? Let's try it again. PTDQ is human minus dvpt. Why is there an add in here? Let's try to parse that line in one of our tests and see. So I was very happy I got my parsing done, and there's a bug in the parsing. Interesting. That's computers for you, or that's programming for you. You can never be sure unless you are sure. See, there's a bug in there. Interesting. So that should be a subtract. Let's write a test for that, and now let's try to fix it. So we're trying to parse this thing. Okay, what's happening? We split on this thing. That appears to work. It's not a number, it is a calculation. How can this part? Oh, there we go. There's a hard-coded add in here. Oh my god. Dead by morning. Dead. So yeah, that's our bug found, hopefully. Yes, our tests are green. So let's try that again. Let's try to calculate root. 152. 152. So at least we know that we have understood the problem and we can deal with very, very small input sets. Let's try to run it on our actual inputs and be amazed by how many CPU cycles this burns. Let's put a timer on there. There we go. Let's go. Oh, that was really fast. That was surprisingly fast. Why am I even worrying about performance? There we go. Part 1 done. Anyone hazard a guess on what part 2 will be? Let's take a look. Before I take a look, let's make sure we don't screw up anything for part 2 or anything of part 1. Yes, version control exists. I like having my two solutions next to each other for posterity's sake. So this was actually, why were we fretting about performance? Maybe for part 2, let's take a look. Part 2, due to some kind of monkey-elephant-human mistranslation, you seem to have misunderstood a few key details about the riddle. First, you got the wrong job for the monkey named Root. Specifically, you got the wrong math operation. The correct operation for monkey root should be equals, which means that it still listens for two numbers from the same two monkeys, but now checks that the two numbers match. Second, you got the wrong monkey for the job starting with human. It isn't the monkey, it's you! It's the human! I love Advent of Code. Actually, you got the job wrong too. You need to figure out what number you need to yell so that Root's equality check passes. That is a brilliant part 2. I love it. So in the above example, the number you need to yell to pass Root's equality test is 301. And then you get the equality check right. This is oh my god, I love it. It will burn our CPU and it will be a larger number than 301. Please, please make this interesting. Okay, so Root has now equality. So let's correct our job list. So let's do I'm just gonna do a correct function that fixes up the jobs with the two things. Human doesn't have to be in there, and does human have to be in there? Yeah, human has to be in there. Human is the thing we're trying to solve for. Yeah, so let's keep the jobs as they are, and let's add a root with a job and a new operation, which is equals. We don't need to parse into equals. We need to apply, yes. I'm a bit all over the place here, so I'm sorry. And that's a bool, interesting. How can this compile? Why is this saying, okay, I'm always returning bools now? I don't get it. Oh, there we go. Let's not. Let's. Interesting. What are we trying to do here? Actually, let's not worry about root too much. Let's extract root from the list of jobs and let's treat it specially. Can we treat it specially? Yeah, and then we have just the left-hand side and a right-hand side to calculate. We can do the same thing and then just check for equality. So yes, it's not an extra operation. We're gonna treat it as a magical separate operation. So let's add root. No, let's not add root. Let's forget about root. So we get rid of root and we get rid of human. No, we don't need to get rid of human. We can patch in a value for human. Yeah, I'm just gonna write an infinite list. So that's 0, whoop, and that should... No, is that not how you... Okay. How do you do an infinite list? How do I do an infinite for loop? Can I not do a range? No? There's languages where I can do just this. Okay, never mind. I just want to loop over all the numbers. And this is one way of doing it, right? Yeah. So this is all the numbers, all the integers we can calculate. Let's call those the numbers or the shouts we do. And then let's patch up job and see whether or not our root... Did I just throw away all the code? I threw away all the code. I'm sorry. Undo, undo, undo. There we go. Code is back. What's the process here? We loop over all shouts and we try to figure out whether the root equality holds. Yeah. So let's grab shouts 0 to get started. So that's our first shout. Which is 1, yes. Then what do? We patch our job where we add human and we add the number we just want to shout, and then we check for root equality. Ooh. Oh yeah, adding takes 2 separate arguments and not a tuple. Getting our parentheses right. There we go. So now we're shouting 1 for this single simulation run, and now we just check for equality. Yeah, we just check for equality. Let's not remove root from the jobs because we kind of need it somewhere, and I'm not gonna parse it again. So let's call the root job the root job we pull out. Oh no, and then we need to have parsed it into something, right? Okay, I'm gonna introduce a new operation called equals, and it will return. Let's not match on it. If we're trying to calculate root in another different way, we're doing something wrong. So is root egg? Root is not egg. Interesting. Why is it even parsing? Shouldn't it not be blowing up? Ooh. What is happening? Why is it parsing? It is parsing into something. What is parsing? So we have our 1, we have our patched human. Human is shouting 1, so that's correct. And then we try to find root. And root is saying add. Oh yeah, we need to manually patch it. Yeah. So we added human, but we also need to patch root. Yeah. So original root is the root we have right now. Okay. I'm sorry. I'm not fully awake yet. I cannot keep using that excuse. This is just programming, folks. Sometimes you get lost in details and you're having internal monologues while you should be talking to your partner or to your rubber duck. That's programming. So yeah. Let's destructure original root into orange root, and that's a calculation. There we go. It knows it's a job, and then I'm destructuring into a calculation, and the compiler is not complaining? What? What happens if I destructure into a number? Who? How can that even work? Oh, I need my parentheses. And then I get my green squigglies. Okay. I don't even know what this syntax means. What does it mean if I do let calculate blup is orange root? What is this? It's a function? It's a function called calculation, okay. Ooh, that's super confusing. And even my IDE is getting confused. It's highlighting it in a different color. That's what threw me off. But okay, digressing. We have our root original, and then we add our replaced calculation for root. We don't need to have that in the map, right? No, we don't. So let's remove root from the equation. We have it right here. And then we just calculate left, right, and we figure out whether they're equal, right? Original root is not equals. That's the third time I'm... Okay, there we go. I promise this will be the last time I try something stupid. I tried to pattern match on it being equals the operation, but it's not. It's add originally, so... Slap on the wrists. Okay. These are the patched jobs. Don't need root, we have it already. And now let's calculate left number and right number. And for calculate to work, we need the jobs as well. And those are the patched jobs because we need the human in there. And then return equality, yes or no. Are these numbers the same? There we go. Easy peasy. And that should work for 301, right? Ah, that was a 0. I think we might have to take a look at what we're doing a bit more closely. If there's a 0 in the actual values, we might have to take a look at what we're actually calculating here. Maybe there's some kind of sequence or system to the madness. But I think we are done with the naive approach. If we now just, instead of take one shout, we take 301. 301. That should bring us to an equality, right? Yes, it's 150, 150. So Okay, this is an approach that could potentially work. So let's write a simulate given jobs and a shout, and that's the whole thing we're doing here. And actually, yes, we do need to patch inside the simulation function because we are changing the human value. So yeah, that's it. And let's now run it for every number. This will hurt for our input. Let's grab shouts. You know what? And let's grab jobs as well. So these are all functions we need to do the work, and this is actually doing the work. So we have our jobs parsed, we have our shouts, and then we do find the first shout where simulate shout. What does find? It is. We need to pipe in the jobs, I'm sorry. So yeah, that's the thing we need. And that should stop for 301 for our example. And it stops in a reasonably fast amount of time. So if we do this for our input now, and we hold on to our seats, yeah, let's see. Yeah, it's off to the races. It's off to the races. We have several avenues for optimization here, right? We can... What can we do? We can try to keep it brute force like it is, but try to make it faster. Or we can try to be smarter. And in order to get smarter, we need to figure out what's actually happening in all those calculations. How long are we in? 42 minutes? I'm debating. I'm not sure that I can solve this in 20 minutes. But let's take a first step. Let's print out the left and right end numbers. And see what kind of numbers we're getting. Maybe there's a system in there. Maybe we need to print out the job number as well, or the shout. So yeah, let's see what's happening. What song is playing? That's not the memory cards, is it? Oh god, I'm I'm streaming, not the music. I thought I was streaming. There we go. Sorry, got distracted. So yeah, timing is now on. Jobs are now parsed. Shouts are now generated. And let's see what we're actually calculating here. Oof. Are those numbers going up or down? They're going down, right? They're going down very slowly. Let's grab some of those. Let's see how far off those two are. That's work stuff. Let's get rid of that. So we have this and this. Yeah, let's just grab one line. It seems like there's some kind of... It's even... If you look at these three runs here, do they not look similar? Yeah, there's 3 times the same number every time. There's system. There's a system in the madness. There's a mathematical sequence in here. So we have 30 and then looks like we have repeats of 1, 2, 3, 4, 5, 6 now, and then 3, and then 1, 2, 3, 4, 5, 6 now, and then 3. There's some kind of sequence going on here. Maybe we don't even need to worry. Maybe we can start with a larger seed number and get closer to the mark. So what are we seeing here? How far apart are these numbers? Oh, they need to decrease by a factor of 10 and then some. yeah, I think this might be actually a way to go about it, not having to brute force it. Now that I see these numbers, brute forcing it might not be the way to go. So this will be finding a sequence, right? 3 times, 3 times, 3 times. Why were there 6 repetitions? If we go down, if we have it calculate for a while, we have those 3, those 3. Why was I seeing more than 3? I don't see it anymore. Let's grab the... So what's happening? Then we drop 1 and then we drop 1. What's the system here? What's happening? 935 to 820, that's a difference of 115, right? Yeah, there's always a difference of 115 and then it repeats for 3 times. How would it do repeating for 3 times? Would there be some kind of modulo operation in there? No, we only have 1 equality check and that's root. We are only doing plus, minus, times and division. Interesting, interesting. I'm going to need to draw out stuff, and I don't like doing that live on stream because then I I get lost into details, and that's not the most interesting thing to watch, right? So I'm going to close the stream here. It was very fun. I am confident I can solve today without looking up spoilers. Let's see if that's the case in a couple of hours. So yeah, this was part 1 of day 21 already. I hope you enjoyed. At least I had a lot of fun, at least. Very cool twist on part 2. I don't think brute forcing it will be the right way, but we'll see. We'll see where we get. Thanks for watching, and see you next time on Advent of Code and F#. Bye bye. So this is me from the future. Hello again. I just figured out, or I got my second star. That's at least how I would phrase it for day 21. I didn't solve it with code, actually. I solved it with a human binary search, and I wanted to quickly summarize that so I can get this day under my belt. What did I do? We left the stream with me realizing, ooh, there's maybe a sequence in the numbers here, and I didn't even bother looking for the sequence. I just took a look at what was happening, and given a number, I saw that the shouts were always if I was going from number 1 to 10 as possible shouts, we could have the human do. The resulting numbers of one of the 2 equality operands was monotonically decreasing, so it was getting smaller and smaller and smaller the larger the shout number was getting. So I just did a digit by digit binary search to figure out the most significant digits of the number until I got close enough for my brute force algorithm to actually hit the correct value on the right hand side or on the other side of the equality check. And yeah, so that was not the most programmatoric way of doing things, but that's what I love about Advent of Code. You can sometimes just take a notepad and doodle something out. For sure, there's ways to do this programmatically as well, and there's probably alternative solutions there. I would suggest you take a look at the subreddit for Advent of Code. There's some great summaries and alternative approaches on there for every day. But that's how I did it. Bit searching, doing a binary search to find the most significant digits for this starting seed, and then just look around, look a bit further into those numbers or that area. Really fun part 2, really fun twist. I love this puzzle. The previous days were a bit hard on my on my brain, so I didn't get to finish all of those. But yeah, day 21 approved. So sorry, thanks for watching, and I'll see you tomorrow for Advent of Code in F#. Bye bye.